Chalo. In the last lecture, where did Vishnu, Netra, where did we end? I guess we ended at the Arrhenius equation. Yes. We stopped at the Arrhenius equation. Today we are going to start with the question first. We stopped at the Arrhenius equation, isn't it? So Arrhenius studied rate constant with respect to what? Yes, Yazira, Jyotsna, Vishnu, Netra, Vishwanath. Arrhenius studied rate constant with respect to what? Why did he study rate constant? Yes. Why did he study rate constant? What is there in the Arrhenius equation that is your first order reaction, second order reaction, your rate constant, integrated rate equation? What is not there in that you have in the, yes, that you have over here? Come on, tell me. Your Arrhenius. What was the equation? Everyone, what was the equation of Arrhenius? Come on, turn on your cameras. Everyone, turn on your cameras. Shrutika, Dhaneshwar, Yasira, Netra, Jyotsna, Vishnu is already on. Yes. Arrhenius. No one is revising. I am telling you, this is damn serious. If you do not revise, it is not possible. It is not in my hand. Yes, Arrhenius is nothing but correct, Jyotsna. It was K is equal to A into E raised to minus EA by RT. EA, what is EA? Everyone, what is the EA? You have written it in your book. Please check your book. EA is what? What is an EA? Correct, Jyotsna. Yes, Vishnu, Vishwanath, Shrutika, Netra. What was the EA? Yes, what was the EA? See, no one has revised. Yes, EA is nothing but your activation energy. EA is nothing but your activation energy, and T is nothing but your temperature. With respect to temperature, your Arrhenius studied the rate constant. With respect to temperature, Arrhenius studied the rate constant. Correct? He increased the temperature just by 10 degree. The rate constant directly doubled. The rate constant directly doubled. Yeah. And we did one more formula over here. We took the logarithm on both the sides. So if I take the logarithm, it will become ln K is equal to ln A minus ln E plus ln E raised to minus EA by RT. Yes, this is what we have done. Log A plus log B. So ultimately, the final equation we had got was ln K is equal to minus EA by RT. Yes. Plus, yes, plus ln A. What was the x-axis in this case? Jyotsna, Vishnu, Netra, Shrutika, Dhaneshwar, Akash. What was the x-axis in this case? If I draw the graph. Yeah, come on, tell me what is the x-axis? If I draw the graph. Yeah, no. Time. Where do we have time, Jyotsna, over here? Do we have time in the whole equation? Do you see the time, Jyotsna? Time is the small t. There is no small t in the whole equation. Please remember. EA. No. EA is a constant. What you all have forgotten, I know. This was your Y. Yes, this was your Y. This is your M. This is your X. M is nothing but minus EA by R. And X is nothing but 1 by T, not only T. It is 1 by T. That is your X. This is your minus M. This is your C. So if I draw the graph, everyone, if I draw the graph, yes, This on the x-axis we have 1 by t, on the y-axis we have ln k, the negative intercept like this, and the slope minus ea by r. Minus ea by r is nothing but your slope. Is it clear? Yes? Come on, give me yes, yes in the chat box. What has happened to everyone? Is it clear? This is what we had done. This was one of the equation. Yeah. Then also we did one equation with the variable temperature, with the two temperature. What was that equation? It was ln k2. Yes, the last equation that we did, ln k2 over k1 is equal to, yes, is equal to ea. Yes, ea 2 point, over here ln is there, so I'm not adding 2.303 ea by r. Yes, 1 by t1. Over here it should be minus 1 by t1 minus 1 by t2. Similarly, ln k2, if I convert ln to log, how do I convert? Jyotsna, Vishwanath, Vishnu, Shrutika, ln to log. ln to log, how should I convert? Yes, I can multiply it by 2.303. So that I'll take it in the denominator. So log k2 over k1 is equal to minus ea by 2.303 r 1 by t1 minus 1 by t2. What is the t1 given? Nothing till now. So I can write it as cross multiply. If I cross multiply, it is t2 minus t1 over t1 t2. Come on, make it a box, write it down. Write it down. This was with respect to temperature. With respect to temperature. Come on, write it down. Even if you remember this equation, then also fine. No issues. Come on, write it down, everyone, and done in the chat box. Vishwanath is done. Jyotsna is done. Come on, write it down, everyone. We have to do one numerical on this. Yazira is done. Vishnu is done. Okay. So look at this numerical, everyone. Integer type of question are more of a possibility in this numerical. Yes, over here. Come on, read the question for me. Read the question for me. Take your time. Read the question. Understand the question. Important is understand the question. Yes. The first order rate constant for the decomposition of calcium carbonate at 700 Kelvin is 6.36. So the first order rate constant is given. So rate constant we can say K is given. Yes, first write down the K. K is given as 6.36 into 10 to the power minus 3. T1 is given as Jyotsna, T1 is given as Yazira, T1 is given as 700 Kelvin. 700 Kelvin. Then you have, yes, then you have T2 given as 600 Kelvin. Yes, the first order rate constant for the composition of calcium carbonate at 700 Kelvin is this. Okay, and activation energy is given, EA is given, that is 209 kilojoule per mole. Okay, its rate constant at 600 Kelvin is, so rate constant is asked, so K 600 is asked, and that also in 10 to the power 6, that means over here there is some value. Come on, this is a JEE type question directly from the JEE book. Come on, try. On, try everyone. What we have over here, we have to take the two equation again. That is ln k1, correct? ln k1 over k2 is equal to, yes, ln k1 over k2 is equal to EA by R is equal to EA by R. Yes, the formula that we have done just now. Yes, the formula that we did just now. That is 1 upon, everyone please look over here, 1 upon this formula we have just done it. 1 upon T2 minus 1 upon T1. I can write it 1 minus T2 minus T1 because this minus sign I have made it plus. This minus sign I have made it plus. Is it clear till over here, everyone? Yes or no in the chat box? Okay. So ln, if I convert, everyone, if I convert ln, it will become what? 2.303. Yes, 2.303 K1 by K2 is equal to, yes, K1 by K2 is equal to EA by R. Do we know the values? Can we put it over here? Did we miss something over here, everyone? Did we miss something over here? Please check. Log. Yeah. Where will the log come? Yes, Vishnu? Vishwanath, where will the log come? Where did the log come? K1 by K2. Right, so 2.303. This 2.303 log K1 by K2. Log K1 by K2 is equal to what, everyone? Log K1 by K2 is equal to EA by R1 over T2 minus T1. Yes, what is the T2 given as? Students, what is the T2 given? T2 is given as, yes, 600 Kelvin. T2 is given as 600 Kelvin. T1 is given as 700 Kelvin. T2 is given as 600. T1 is given as 700. Your electrode EA, sorry, not electrode potential, your activation energy is given as 209. Activation energy 209. Gas constant, we all know that is 8.314. 8.314. Yeah. So go on, calculate the rate constant, everyone. Calculate the rate constant for the second equation and then substitute it. For K1 they have already given. For the K1 they have already given, that is 6.36 into 10 to the power minus 3. For the K1 they have already given. So from this everyone, what we can do? Yes, what we can do, Vishwanath over here, Yazira, what we can do, Vishnu? Yes, come on, look at it, everyone. Come on, solve it. Try to solve it. If you do not get it, please ask me. I'll explain you. Come on. First, try it on your own. Chalo, try it on your own. Come on, everyone. Try it on your own. Yes, what is the answer, everyone? What is the answer you are getting? I hope you know what you have to find out. Yes? I hope you all know what you have to find out. The rate constant in second. 600 rate constant in second at 600 Kelvin is X that you have to calculate. Come on, no one till now. Come on, try it, everyone. What happened, Vishwanath? Come on, try it. It is fine even if it is wrong. I'll help you. X is equal to 16 according to the Yazira. Very good. Very good, Yazira. Come on, everyone, look at it. It is not that difficult. It is very easy. Very easy. So over here, so I'll only do it. K1, yes, K1 is given as what? I hope everyone can see the screen. Yeah. So over here, log K1 by K2. Over here, log K1 by K2. Correct? Log K1 by K2 is equal to EA by R is equal to EA by R. Over here now 2.303. 2.303. Yes, 2.303 into, yes everyone, EA by 2.303 multiplied by 1 by T2. What is the T2? Jyotsna, Vishwanath, Vishnu, what is the T2 over here? T2 is nothing but 1 by 600 Kelvin. T1 is 1 by 700 Kelvin. 1 by 700 Kelvin. Come on, solve this, everyone. Ultimately, you will get the log value, and the correct answer, everyone, is nothing but 16. The correct answer is 16. If you solve it, you'll get the answer. Vishnu, Yazira, Shrutika, is it clear? Is it clear? Okay. Just give me 2 minutes, everyone. Till then, I'll give you one question. You do it. Okay, I'll be back in a minute. Till then, I'll give you one question. Did we do any tabular type of questions? Okay, let us do the tabular type of questions. Chalo. Is it visible, everyone? So tabular I'll give after I come. Till then, 'Till then you do this. Chalo. Let me see who can do this. Let me see who can do this. 2021 question itself. Okay. 2021. 2021 question is there. Is it visible, everyone? Chalo, try, everyone. Try this. I'll be back in a minute. I have to bring my bottle. Come on, try this. Is it clear, everyone? Please try this. I'll be back in 2 minutes. Yes, the nearest integer question. The nearest integer question. Come on, everyone. The nearest integer question. Come on, try. Not that difficult. Come on. Not that difficult. It is a first order reaction. Clearly given. Okay. Before this, okay. Wait. Before this, you solve this. 107. It is actually 108. 108. Okay, before doing this, we still have to do little bit of concept of that. Before doing this, solve this. Chalo. Solve this. Regarding the half-life itself, solve this. Solve this, everyone. I told you today we are going to do numericals. You have to revise, but very few of you have revised. Very bad. So try everyone. Integer type of question again. You got the answer. You got that answer. Okay. Tell me. For the previous. Yes, it is 108. It is 108. It is 108. Very good, Dharneshwar. Very good, Dharneshwar. Dharneshwar has got the answer. Come on, everyone. I expect you to do this. Not that difficult. Very good, Yazira. Only Dharneshwar and Yazira has got till now. Come on, everyone. Very good, Vishnu. Come on, Jyotsna, what will be the answer? So I'll solve it quickly. Look over here. What is asked? The reaction half-life time required is given. Okay. Round off to nearest integer. Round off to nearest integer it is given. Okay. So what is the formula that we are going to use? Half-life of 1 minute. Okay. Time required for 99% completion. Okay, fine. So we know the T half for the first order, isn't it? We know the T half of the first order. Yeah. Okay. Jyotsna not getting it. Fine. Look over here. We know the formula for the first half. We know the formula for the T half of the first order. Yes. What is it? Jyotsna. What is the formula? T half is equal to yes 0.693. Yes, everyone. What is the formula? 0.693 K. Correct. So from this K is equal to 0.693 over T half. Okay, they have given you half-life of 1 minute. Okay, they have given you half-life of 1 minute. Okay, that you have. So from the half-life, you will get the K. Okay, from the half-life you will get the K. And what is the first order formula, Jyotsna? The first order formula, K is equal to 2.303 T log of initial concentration over final concentration. Now it is given percentage. What did I tell you? If there is a percentage, Vishwanath, what you have to take? Number. Initial concentration as always and always you have to take it as 100. Always and always you have to take it as 100. Okay. So K is nothing but 0.693 over 1. Yes. K is nothing but 0.693 over 1 because they have given half-life is 1. So K is 0.693. Okay. So I'll write over here 0.693. What do I want? I want T, Jyotsna. So T, I'll take it to that side. So T is equal to 2.303 over K is 0.693 log of initial concentration. Now, whenever there is a percentage, Jyotsna, we take initial concentration as 100. Divided by 99.9% is done. That means final that is left, final concentration is 0.1. So if you solve this, you will get the answer. Yeah, if you solve this, you will get the answer. How to solve this? 0.1. Yes, you have 0.1. Come on, solve this. I can solve this as log 100 minus log 0.1. 0.1 I can write it as 10 to the power minus 1. 100 I can write it as, Jyotsna, 10 to the power 2. Correct? So this is nothing but 2 into log 10. That is 2. Minus 1 comes first. So minus plus. So 2 plus 1, 3. So what I have got, 2.303 into 3 divided by 0.693. Isn't it, everyone? Is it clear? Is it clear? Yeah. So if you solve this, this will come around 10 because this value will come around 6.9. This is 0.693. So ones are, tens are. So the correct answer to this question, everyone, is nothing but 10. Is it clear, everyone? Yes or no in the chat box? Is it clear? Is it clear? Come on, those who do not know, write it down. Come on, I want yes from everyone. Is it clear? Yes, Ira, is it clear? Vishnu, is it clear? Come on, those who do not know, please write it down. Shrutika, Akash, please write it down, everyone. Those who have not got the solution. That is what I am telling you. Please solve these questions. If you solve this question, then and then only you will be able to do it. You have to solve question. There is no option. Is everyone clear till over here? Yes or no in the chat box? Come on, go ahead. Okay, fine. Sure. Let us start with our one more thing that is left is catalyst. Yes, everyone, what is a catalyst? Yeah, what is a catalyst? Yes, Rutika, Jyotsna, Vishwanath, what is a catalyst? Come on, tell me. This is easy. You should know this. What is a catalyst? Yeah, what is a catalyst? Increase the rate of reaction. Okay, Vishnu. What else? Come on, give me catalyst. What is a catalyst? PT and ND. What is ND, Vishwanath? Which does not participate in reaction. Jyotsna, Shrutika, Netra, Akash. What is a catalyst? Come on, tell me. What is a catalyst? Increases the rate of reaction. Now you are in the 12th standard. Okay, you should not say it just increases the rate of reaction. How does it increases the rate of reaction, Jyotsna? How does it increases the rate of reaction? Okay, it will not undergo any reaction but increases the rate of reaction. See, again, It is not the correct word to say it will not undergo any reaction. It does undergo reaction, it does. But only thing is, it comes in the first step and goes out in the last step as it is. Okay, it comes in the reaction, it reacts also. But again in the last step, it again detaches and again go as it is, it entered in the system. Now catalyst, do not say it increases the rate of reaction. Always and always in your definition include how does it increase the rate of reaction. Look at the diagram, everyone. So the black one is with the black one is without catalyst, the dotted one is with catalyst. Now over here, everyone, with catalyst you can see it is taking a shorter path. It is taking a shorter path. So since the path is shorter, yes, since the path is shorter, the reaction is happening faster. Now path is shorter, what is the meaning of that? That peak, everyone, this peak is called as what? Yes, Jyotsna, Yazira, Vishwanath, this peak, I guess we discussed this in the last lecture also. This peak is called as, yes, this peak is called as what? Yazira, Shrutika, that peak is called as Dharneshwar, Darshan, Vishwanath, that peaks are called as what? Come on, you should know this. We have done this, no? That peak is called as activation energy, minimum amount of energy required. That is nothing but, Vishnu, activation energy. On the left hand side, you have the reactants. On the right hand side, you have the products. So this much amount of energy barrier it needs to come over. Yeah. So what happens in the catalyst? It decreases the activation energy. Write it down, everyone. Catalyst decreases the activation energy. Catalyst decreases the activation energy and hence the rate of reaction increases. Catalyst decreases the activation energy and hence the rate of reaction increases. Is it clear, everyone? Is it clear? Okay. So over here, the activation energy required for the catalyst is very less, while the activation energy required for a compound without catalyst is very high. Okay. So your catalyst does not affect any change. It does not, write down in the bold. Catalyst, everyone write down in the bold. Catalyst does not alter the delta G of the reaction. Catalyst does not alter the delta G. Does not alter the delta G, that is Gibbs free energy of the reaction. Come on, write it down. Delta G of the reaction. So catalyst does not alter the delta G of a reaction. Nothing much, just little bit information of catalyst you have. Is it clear till over here, everyone? Is the catalyst part clear? Okay. Sure. Let us go ahead. Then you have something called as collisions. Okay. Collision. See, whenever the reaction takes place, whenever the reaction takes place, always and always remember. So what happens? There are few factors on which the reaction is dependent. For example, you have reactant A, reactant B. Okay. Whenever the reaction takes place, this reactants colloids. Yeah, this reaction colloid. So reactants, when the collision takes place, what happens? The reactants colloid convert into product, you get the product. Simple. Colloid, exchange of energy, convert into product. Colloid, exchange of energy, convert into product. But it is not necessary each and every collision will convert it into product. Each and every collision will not convert into product. Okay. So for that, what is required? The very first requirement is the proper orientation. Is what? Is the proper orientation is required. If the orientation is not proper, yes, look at this example. If the orientation is not proper, no reaction will happen. No reaction will happen. Look at this. You must have done this in the school, your SN2 mechanism. This is your SN2 mechanism, everyone. Look over here. SN2 mechanism. This is what? This is nothing but a nucleophile. This is nothing but a nucleophile. Come on, tell me what is a nucleophile? Vishwanath, Jyotsna, Yazira, Netra, what is a nucleophile? Yes? Nucleus seeking. Give me more proper answer. No nucleus seeking. Electron rich. Very good. Correct, Jyotsna. Electron rich, or basically it contains a negative charge. Okay. Now this OH minus, correct Vishnu, this OH minus wants to attack the positive carbon. Anyhow it wants to attack. Okay. So what happens? Over here, bromine is electronegative. What is electronegativity? It is tendency to pull electron towards itself. And due to that, even your bromine is negative. Carbon is positive. So when OH is going to attack carbon at the positive center, bromine is in between the both. So if OH tries to attack from the front side, is the attack possible? Is the attack possible? Bromine itself is negative, OH itself is negative. So if negative, one compound negative is already there, and if one more negative, yes, if one more negative comes close to that, yes, correct Dharneshwar, it will not take place. Yes, it will not take place. The attack will not take place because negative will repel. The negative, Jyotsna, the negative will repel. The attack itself will not take place. The bromine will not allow the OH to go through him and attack the carbon. That is your improper orientation. So that means, yes, the collision has taken place. The collision has taken place, but since the orientation was not proper, you did not get any product. The reaction did not happen. Is it clear, everyone? Yes or no in the chat box? Is it clear? Is it clear, everyone? Again, okay. Look over here. Vishwanath, look over here. I'll write it. You always understand when I write only. Okay, look over here. I have a SN2 reaction. What is this? This is nothing but a methyl bromide. Okay, this is nothing but a methyl bromide. Now, Jyotsna, your bromine is electronegative. That means what? Tendency to pull electron towards itself. And hence, it is negative. Carbon, since the electron is going away from the carbon, carbon is positive. Now, OH minus is there as a nucleophile. That means electron rich or a negative charge. Now, Vishwanath, OH wants to attack the carbon. OH wants to attack the carbon. But the Br is in between. So, if OH attacks from the front side, the Br will repel and you will not get any reaction. No product. Is it clear, Jyotsna? Is it clear, Vishwanath? Yeah. So over here, the OH, since bromine is there, OH cannot attack. So what does OH do? OH is desperate. It wants to attack. So what does OH do? Go from the back side. Now on the back side, you have small poor hydrogens. Yeah. What they will do? Small poor hydrogens do not have any negative charge. So yes, OH will attack from the back side, and yes, that is your proper orientation. That is nothing but your proper orientation. See, look over here. OH attack from the back side. You got your product. Br has gone out. So OH is the product. Br is the byproduct. And hence you got your product. Is it clear, Vishwanath, Yazira, Shrutika? Is it clear? So orientation is very, very important. All of the collisions do not give you product. All of the collisions do not give you the product. The collisions that give you the products, everyone, these are called as effective collisions. Come on, write it down. Write it down. So in the molecules colloid with the threshold energy. Okay, previous slide. Okay. Okay, write it down. If you want, you can write down this also. Come on, write it down. Proper orientation, improper orientation. Write it down and done in the chat box. Come on, write it down and done in the chat box. And next one is done. Akash is done, Yazira is done, Jyotsna is done. Okay, now look over here. So write down the effective collision. It is nothing but when molecule colloids, they reach the threshold energy. What is required? Threshold energy, proper orientation, yes, and they form a new bond. Threshold energy, proper orientation, and they form a new bonds to form products. That is nothing but effective collision. So collision A, collision B, yes, takes place, gives you product. That is nothing but simply effective collision. That is nothing but simply effective collision. Simple. If it does not give you your desired product, it is not effective. It is not effective. Simple as that. Simple as that. I'll write it down and done in the chat box. Effective collision. Okay, this can make a statement type of question, Shrutika. This can come as a statement type of questions. Okay, be careful. We'll do all the difficult numericals, and you'll have some easy statement type of questions, and you will not be able to do it. So it should not happen like that. Yeah, it should not happen like that. Okay. Now look over here. So that's why we have, for a bimolecular elementary reactions, that's why we have a new formula now. That's why we have a new formula. Okay. So you tell me one thing. If the number of collision increases, what will happen to the rate? Yes, what will happen to the rate of reaction? Will it increase or decrease? Understand my question, Shrutika, Vishnu, Yazira. If number of collisions increases, the rate of reaction will increase or decrease? Yes? Correct, Jyotsna? Yes, Yazira, Shrutika, Vishnu. If the number of collision increases, the rate of reaction, will it increase or decrease? Yeah? Correct? Perfect, Dharneshwar, perfect, Vishnu, perfect, Jyotsna. It will increase. And that's why we have a formula. Yes? Rate is equal to ZAB. Okay? Rate is equal to, okay, Shrutika, rate is equal to ZAB e raised to minus EA by RT. It is same as your Arrhenius factor. Arrhenius equation, only difference, Jyotsna, over here is you have now new term ZAB, and write it down, everyone. ZAB is nothing but collision frequency. Please mention it. ZAB is nothing but collision frequency. ZAB is nothing but collision frequency. Yes, ZAB is nothing but the collision frequency. I want to write it down. Just these 2 lines, fine. And tell me done. Done. Okay. So collision frequency, as we have discussed, everyone, it is not necessary that all of the collision will convert into product. It is not necessary. It is not necessary that all of the collision will convert into product. What is important is the orientation. If the orientation is proper, then yes, it will convert into product. If the orientation is not proper, it will not convert into product. So only depending on the collision frequency, we cannot say that rate will increase or decrease. And hence, in our formula, Yazira, in our formula, we have added one more term, that is rate is equal to P into, come on, write it down, one more formula, rate is equal to P into ZAB e raised to minus EA by RT. What we have done, we have added one more term, that is P, and P is nothing but your steric factor, or basically you can say effective collision. P is nothing but your steric factor or effective collision. So obviously it does not only depend upon the frequency, but it also depends upon the, yes, it also depends upon your orientation. And that's why we have included one more term, that is P, steric factor, to take account of effective collision. So it depends upon the effective collision. It depends on the effective collision. Come on, add this term, P into ZAB e raised to minus EA by RT. Come on, write it down, and done in the chat box. We'll take a break after this. Come on, write it down. Noted. Now, whatever the numericals we have missed, let's do that. Yeah, and I'll also teach you how to do the tabular numericals. We have not done that yet.